Okay, here on Desmos, I've kind of proved that this is the answer. I graphed this original fraction as a rational function, which gave us this curve over here. And then I also graphed this version of the function, which is the partial fraction decomposition of the original fraction. Question is, where did I get these values up here? And if you go to Desmos, which I'll send the link to this graph in the final answer, you'll see that these f and g overlap each other identically. So how do you do that? Well, here's the original fraction, and there's theorems about how to find the partial diffraction composition, but these are linear factors, and that means that you have to be able to decompose this into fractions of the form a over x minus 3 plus b over x plus 2 plus c over x plus 2, the quantity squared. If this had been a 3 here, you'd have another one, plus d over x plus 2 to the third power. Okay, and now the idea is to, undo. I just wanted to get rid of, okay, I'll leave it like that. Is to multiply every term of this equation by the LCD of all the denominators, which is x minus 3 times x plus 2, the quantity squared. If you do that, you get this. And you don't have to equate coefficients yet, it turns out. If you say, well, you know what, I'm going to let x equal to -2, and if I do that, this first term becomes 0, and so does the second term. And so we can solve for c just by letting x equal -2. And there's what it looks like. When x is -2, you get c is -43/5. When x is 3, the b and the c terms become 0, and I can solve for a. When x is 3, I get 25a on the right, and I get 88 on the left, so a equals 88/25. Now to find b, you have to equate coefficients, which means you multiply all this stuff together, and then you can say, well, the constant term has to equal 19, or the linear term has to have a coefficient of 2, or the x squared term has to have a coefficient of 7. So if I write it out, if I square this first binomial, I get x squared plus 4x plus 4. If I multiply these two binomials together, x squared minus x minus 6. If you picture distributing a over the x squared, b over the x squared, those are the only x squared terms you're going to get. So ax squared plus bx squared has to equal the term that has an x squared in it, which is 7x squared, which means a plus b has to equal 7. We already know that a is 88/25, so if I subtract that from 7, I'll get the value of b, and there's the value of b right there. So that means that this original fraction can be written as, put 88/25 right there, put b 87/25 right there, and c was -43/5 right there. And that's your partial fraction decomposition, which is what this is. Of course, you could write this differently. You could write this as 88/25 times the quantity x minus 3 if you wanted to. And similarly for the other terms. Okay, but that's the idea. If you have any questions, post a comment. Hope that helped. There you go.